everyone, and in our last class I gave you an introduction of mechanical properties of matter, and we also talk about the stability of atoms, that how atoms are stable. We came to know that atoms consists of electrons and nucleus, and then the nucleus consists of protons and neutrons. It contains many other subatom particles, but these two are fundamental and these are found in every atom. Okay, so protons and neutrons are held together due to nuclear force, we came to know, and the nucleus and electrons are uh, bind together due to the Coulombic force of attraction, and that is your electromagnetic force. Okay, and now in this video we will deal that how atoms are held together, how different atoms are held together. Not we are not going to discuss the stability of a single atom. We have done it in our last video, and if you have not watched it, then you may please go there and watch there to make your concept clear. Okay, so in this topic we are going to study about the stability of different atoms, okay, in a matter, because we know that matter consists of a group of many atoms. They may be 100,000, a million, or a trillion atoms. Okay, so let's know it. So when two atoms are brought together, here is atom and here is another atom. Okay, so when any two atoms, okay, this is a simple rule and is applied to both atoms and molecules. Okay, so when two atoms are at a very large distance, okay, they are at a very large distance, and let takes this distance r is equal to infinity. Okay, a very large distance between these two atoms, then in this case the potential energy will be equal to 0. Okay, and if they are at a very large distance, then negligible force acts between them and that will be your attraction force. Okay, but when two atoms are atom 1 and this is atom 2, when these two atoms are bring uh, somewhat at a considerable distance, then they starts attracting each other. And here the potential energy decreases. Okay, the potential energy decreases, and here attraction works. Okay, so when attraction works, when atoms are farther, but not so farther. Okay, farther. Now when atoms are at some point of time, at some distance, let's take that distance r is equal to r naught. Then at some distance, when atoms are brought together at a distance, at a fixed distance, this is a fixed distance, this is a constant, this is not going to change, and actually this distance is different for different things. Okay, like metals have different things, water have different. So when atoms of different elements are brought at such a fixed distance, which is a constant, then at this state they are in equilibrium. Equilibrium means their potential energy is at the lowest point. Okay, means they have the minimum potential energy at this distance. Okay, but when these atoms are brought more nearer to each other, like just here atom and this is atom, then the potential energy starts to increase. The potential energy starts to increase, and there is a repulsion. Okay, so very near. So when two atoms or molecules are brought very near to each other, then repulsion acts, and here the potential energy started to increase drastically. Okay, so you know the equilibrium state of matter here. Okay, so when atoms are at very large distance, r is equal to infinity, then potential energy is 0. When they are brought to very near, when they are brought near but not so near, then attraction force acts and potential energy decreases. So potential energy is 0, but when potential energy decreases, then potential energy is negative here. Okay, so attraction works. And lastly, when they are put at a certain distance, then they are in equilibrium state, means the potential energy is lowest. Here neither attraction nor repulsion takes place. No attraction and no repulsion. But when they are bring very near to each other, then repulsion is okay, and the potential energy starts to increase, because a work is done on the atoms to bring them together. Okay, like we have two atoms, they are at a very large distance, then potential energy is zero, attraction works together, potential energy decreases, negative, but at a certain distance the potential energy is minimum. But after this, work is to be done to bring them together, and this is what we called non-equilibrium state. So at equilibrium state neither attraction nor repulsion takes place, but from further decreasing the distance between them, this causes repulsion, and that is their potential energy increases. So remember one thing, when atoms are further, attraction, but when atoms are very near to each other, then repulsion takes place. Okay, so thank you.